In this video, let's talk about how to draw the Lewis structure for the perchlorate ion. All right, so the perchlorate ion is ClO4 minus. All right, so the first thing I want to do is write out my atoms and how many of each I have. From the periodic table, we know that chlorine has 7 valence electrons and oxygen has 6 valence electrons. All right, I'm doing this because I want to be able to tell the total number of electrons that I have to place. So 4 times 6 is 24, right? Because we have 4 oxygen atoms. So this is 24 electrons. Plus, I'm going to add the 7 that chlorine gives me. Now remember, this is an ion, so if we see a negative, in this case it would be -1, that means that we have to add 1 electron, right? That means the compound has gained 1 electron. Now, usually, like we said before, the atom that's within the middle is usually your, I'm sorry, furthest to the left in the molecular formula is usually your central atom. Now, we need to figure out a way in order, and I'm sorry I did not make my total, right? But 24 plus 8 essentially is 32 electrons, right? Now, the first thing I'm going to do is try to form single bonds between, the first thing I'm going to do is try to form single bonds between my oxygen and my chlorine, right? That's the least. I'm not starting too high, I'm not starting too low. I'm starting from the lowest and I'm building up, right? So I could only place 2 electrons. I'm placing 2 electrons in the form of a single bond, right? So we now have 2, 4, 6. We now have 2, 4, 6, 8 electrons around the chlorine, right? Now chlorine octet is this at this point you would say is satisfied, but you got to remember whenever we're dealing with ions, don't be surprised if the octet rule is expanded for atoms that you expect, right? So let's say, for example, oxygen, right? You would expect it to satisfy the octet rule in a neutral structure, but in an ionic structure, it may not, right? It may exceed that, and that shouldn't be surprisingly. Now, at this point, what I'm going to do is actually going to form a double bond between my oxygen and my chlorine, and this put me in a situation where now I could actually fill the octet of this oxygen, right, within the pairs of lone pairs. All right, so now this oxygen is satisfied. I have 2, 4, 6, 8. Right? Now, I could actually do the same thing for about 2 more of these oxygen atoms, right? I could actually form a double bond here and actually put 2 lone pairs around this oxygen. So this becomes 2, 4, 6, 8. Right? So let's count how many total electrons we've used thus far. We've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we've used 20 thus far, and we still have about 12 more to place. Now, because you do the same thing on this side, I can actually form a double bond and give this oxygen 2 pairs of lone pairs. Right? So now we've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Right? So that means that we only have about 6 more electrons to place. Now, you might be tempted to form another double bond between this oxygen and this chlorine. Uh, but what I'm going to do is actually put these in the pairs of lone pairs around this oxygen, right? Because we only have 6 to place. Now, you might be saying to yourself, okay, well, I could actually form a double bond, and you're right, but we would not get this to be equal to 32, right? So let's count out the total number of electrons we've used. This becomes 2, 4, 6, 8, and we have 3 of these, right? So that's essentially 3 times 8, which is 24, 26, 28, 30, 32. Right? Now, all of these oxygens, their octet is satisfied. However, the chlorine looks a bit weird, right? Its octet is expanded. But remember, we should not be surprised because we have an ion. Now, the formal charge, again, we have a negative overall charge, right? And so we have a negative overall charge, and this is actually coming from this oxygen. So the negative charge is actually coming from right? So the negative charge is actually coming from this oxygen, right? And so obviously to complete or ion, we always put it in brackets and add or charge at the top, right? So now if you're wondering what the overall charge of the molecule is, it is still negative, and it's coming from this oxygen, right? We simply take the number of, if you want to calculate the formal charge, we simply take the number of valence electrons of the atom of interest, and then we take the total number of electrons around the atom of interest, right? So you might be tempted to say, okay, this is a double single bond, so this is 2 electrons, but really we're only talking about the electron with respect to the oxygen. So this becomes 1, 2, 3, 4, 5, 6, and the 7 obviously, right? So this is 6 minus 7, and we get that -1, right? So this is where that negative charge is coming from. Again, all our other structures within the molecular formula is neutral.